Everybody, Mr. Odom here, and I'm going to go through problems 11 through 20 from the test. Remember, if you had a different version, the values that are in your problem might be different, but the work that you should do is the same. So for problem 11, I basically need to find the area of a semicircle and add it to the area of a parallelogram. So I use this formula. I plug in my values. My radius is 4 inches. And I get my answer of 85.12 inches squared, which is rounded to the nearest hundredth. For the next problem, the clock problem, first I got to figure out what is the length of the minute hand. So I do that work up here. And then I look at, well, in 1 hour, the minute hand travels all the way around the clock. So I just find the circumference of a circle with a radius of 40 millimeters, and I get an answer. The hour hand only travels 1/12 of an hour, or 1/12 of the distance around the clock. So I calculate the circumference of a circle with a radius of 20 millimeters, and I take 1/12 of it. So I calculate that, and I get this answer, and I need to find the difference, so that's what I do over here. And I get my answer of 240.73 millimeters because I, again, have rounded to the nearest hundredth. The next problem, baseball field. You run around at a rate of at most 8 feet per second, which means you could run slower. And if you run slower, then it will take longer for you to travel around the baseball field. So we got to figure out first what the perimeter is, and I do that work up here, 776 feet. I run at most 8 feet per second. So then I use that and I make a proportion. I do the work and figure out that at 8 feet per second, it takes me 97.1 seconds. Notice 97.1 would be between 90 and 100. 97.1 seconds is between 90 and 100. So there are 3 answers. Because if I run around the field 100 seconds, 110 seconds, 120 seconds, the rate that I run will be slower than 8 feet per second. Okay, so that's how you answer that question. Number 14, basically 2 circles, one of them, I calculate the area of the circle with a radius of x, because the diameter is 2x. Then over here, I calculate the area of a circle with a radius of x, and I can just compare them. It's pretty easy to see that this area is greater than this one. Another way of saying that is this area is less than this one, so that's why it's less than. Number 15, basically find the area of this shaded region. So I take these 4 pieces and I make a circle. All right, and so this shape, original shape, is a square. So if I take the area of a square, subtract the area of a circle, that gives me the area. And so I do that work, and then I make sure that I round to the nearest hundredth, which I do. Okay. Number 16. This one's a lot of writing, but basically I need to figure out what's the area of this triangle. I'll call it number 1. And I do that work over here. And I get an answer of 9 meters squared. For the area of triangle number 2, first I need to calculate the area of each of these colored triangles. And then to find the area of triangle 2, I take the area of the whole square, which I calculate over here, and I subtract the area of the blue triangle and the area of the pink triangle, and that's how I get my answer down here. I'm not done with the problem. I have to add these together, and that's what I'm doing up here to get my final answer. All right, let's see, number 17, rotations of a tire. To figure out those rotations, I have to understand what a rotation is. And basically think of it as there's a point where your tire is touching the ground. And as your bike rotates, let's say it's rotating in this direction because you're moving in that direction. The next time that that point touches the ground again, we call that a rotation. That's also a place where if I cut right there with some scissors and laid my bike tire out, it would just be a line. All right. So how long is this line? To figure that out, I calculate the circumference of the circle, which I do here. I know that that is one rotation, but I'm traveling 300 feet, which I turn into inches so that my units are the same. I want to know how many rotations that is. So again, I do the math, and I get this long, kind of long decimal that I round to the nearest whole number, which is 127 rotations. Number 18, find the perimeter first. And I do that here. I find the perimeter and I turn it into yards because the fencing is $29 per yard. I set up a proportion and I figure out what X is, and that gives me the cost. Okay. Number 19. I have a dog is leashed to the corner of a house, and the corner of that house takes up, the corner of this house takes up 1/4 of the area of the circle. So the dog can run in these three places, which is 3/4 of the area of a circle, or 0.75. So I take the formula for the area of a circle, multiply it by 0.75. That will give me 3/4 of the area of a circle. The radius of the circle is 18 feet, so I square it, I get my answer, and again, I round to the nearest square foot, which I've done. And finally, the last problem, exercise 20, find the perimeter. So I take the two pink pieces of the fountain and I make a circle out of it. I find the perimeter of that circle, and I forgot my units here, so this should be 50.24 feet. For the yellow piece, that's just 1/4 of a circle. So I need to find a circumference of 1/4 of a circle, or 25%, or 0.25, which I use in the formula. So I take the area of a circle, I find 1/4 of it, and I get this answer. Not done yet. I actually need to add those together to get the total perimeter of the fountain. All right, so that's how you solve these problems. As you're going through, if you get stuck, you can watch the video again or watch some of the problems that are still confusing for you, or just go ahead and send me an email and we can go over problems in Zoom during our math help days. All right, so this is Mr. Odom. Have a great day. I am out.